Right, here we go. Okay, look up 7. Wyatt, no one talk. These are the pink. Pink number 7. Wyatt. Yeah, do not. Yeah, once you see how much work is required, you'll be like, oh yeah, don't want to do the work in the pink. Yeah, this will take the whole page. It's number 7. This will take a whole page. Guaranteed. Here we go. Okay, jumping around the room. We start out with the words that says the average value of F. So Ryan Gardner, when you see this, what are you really seeing? Like, what is that?
Like a line? Or a function?
It's definitely a function, but to be honest, 2 points. When someone tells me that that's a function, that doesn't really help me do anything with it. So Anna, what is it really?
I have no idea.
Sarah, what is it?
A formula for finding points.
Yeah, it's a formula for finding points. And what are points really, Sarah?
Coordinates, X, Y, Y value.
That's perfect. They're just X, Y values. When you see that, all you are looking at is a list. So back to Lexi, how long is the list that we're looking at?
Infinite.
Infinite. That little blue box is nothing more than an infinite list of number pairs. If you focus on the numbers and get away from like the terms and things, you'll do far better on the AP test. They don't test you on terminology typically. They test you on understanding what the terminology means. So that is representing a bunch of numbers. And it says find the average value. So we'll go to Jenna. So Jenna, when they say the average value, what's value referring to?
The Y.
The Y. So we've got all these different values. 0 is kind of a bad thing to write, so let's just, I don't know, we got all these different values, you know, different things. We're supposed to find the average of them. 2 points for Jenna. So we'll go over here to Eli. So Eli, without knowing any calculus, can you tell me how to find the average of all these values?
Yeah, you add those values up and divide them by how many values there are.
2 points. You add up the values, you divide by how many you have. So we know that to begin this problem, what we need to be doing is, start over here, we need to add up all the values. So we use this symbol to indicate that we need to add up every value that is computed using this formula. We want to add up every value that is computed using this formula. But technically not every value, just the values starting with an x of 0, then an x of 0.1, 0.2, 0.3, all the way to x equals 2. Please.
Can you just write f of x, or do you need to write out the?
Oh, either way. 2 points for Jenna. Either way. Because we don't have a calculator, I'm going to need the formula. So that's why I wrote the formula, Jenna. If I had a calculator, I would not write the formula. I'd write f of x. Anybody else? Okay. Eli said we have to divide by how many we added up. That's why we include a dx. And that's why we include 1 over this. So we can divide by how many we added up. Good job, Jessica.
Thank you.
Questions? Cool. All right. So that's where we begin. We cannot use a calculator, so we have to use the fundamental theorem to find the value of the integral. So we have to remember how the fundamental theorem works. Inside the fundamental theorem, there's a formula here. It doesn't matter what that formula is called. That's what we have here. It doesn't matter what that's called. It's just a formula. What's important is how does the green relate to the purple? That's what's important. So we'll go to Sophie. So Sophie, how does green formula relate to purple formula?
It's the antiderivative.
Nice. The purple formula is the antiderivative of the green formula. So to solve this integral, we do not solve the integral. We go find the antiderivative of this green formula. Once we have the antiderivative of the green, we can simply plug into that antiderivative formula the limits. And that's how we solve the integral. That's what we talked about last time. Questions? 2 for Sophie. Pretty good? Cool. So, we know what we're trying to accomplish. Let's move this out of the way. We are trying to accomplish, we're trying to calculate this item here. But the first step in calculating that is to do a completely different problem, like a problem within the problem. So what we want to write down is just the integral sign, no numbers. We don't want to work on this yet. We don't want to work on this yet. We just need the antiderivative part. So we write x squared square root x cubed plus 1 dx. And do not put an equal sign because these two items are not equal. I don't want an equal here. These lines aren't equal. I'm starting a new problem within the problem. So I could put a little divider if you want, if that helps. So, questions? Awesome. Okay, to find an antiderivative, the only way we can find antiderivatives is with the formulas. So, we have 5 choices basically, because the other 5 are just expanded versions of the first 5. So we have this choice. We have the antiderivative of x to a number. So we'll go to Trinity. Trinity, does this whole thing, it has to be an exact match. The only thing you can pick is n. You can't pick x. X is just x. So it's kind of a dumb question, but or trick question, I guess. Trinity, is there a way to pick n so that these two black boxes would become the same thing? The look on your face says it all. There's no possible way to simply pick a number here and make this black box suddenly look exactly like this box. So 2 for Trinity. That's telling you that first formula is of no use. It doesn't match. You can't use it. It doesn't help. Question. The second formula is e to the x. That doesn't match. The third formula is 1 over x. That doesn't match. It's not sine or cosine. So none of those match. If you were to write down the expanded version, all the expanded versions do is take the basic version, and instead of writing x, you just write ax plus b. So they don't match either. So we have a situation where none of the rules fit. So for our class, we learned one other method that can manipulate what we have into a situation where the rule will work. And that's about it. We have one other thing after that that's kind of small. But in other classes, further into calculus, you learn more methods. But for us, we just learned one method. So here's where we're at. We have this right here. We need to find this antiderivative. Because it doesn't match any formula, we can't. We have to do something else to get it to match a formula. So, new idea. We are going to do what is called a U substitution. And I have these guidelines here. They're not really rules. You'll see me violate them a little bit in the future because they're guidelines. They are very helpful sometimes. Once in a while I can do something that's a little bit different and it still works. Questions? It's a good place to start. So what I did is I found out that the rule doesn't work. So now I go down this list. I ask myself, am I looking at two functions that are being multiplied?
Yes.
Yeah.
Lily, what are the two functions that are being multiplied?
X squared and then the square root of x cubed plus 1.
Yeah, I've got this black function x squared, and I can circle this one. So it's green function root x cubed plus 1. So I absolutely have two functions being multiplied, 2 for Lily. So this U substitution process might work. Might. It doesn't always work. Sometimes one of the two functions can simply be a constant. So I guess in pretty much any situation you can say you have two functions multiplying. One of them might be a constant. Okay? Both functions, this is where we can be a little bit loose sometimes. Both functions don't have to be of the same form, they often are. So we'll go to Corbin. So the black function, Corbin, which form does the black function take? Which of these 5 forms?
The first one.
First one. And I'm going to refer to this box as the something. What is the something for this first black function over here?
X.
And what's the end?
2.
2 points for Corbin. It says right here, you're going to pick U as the something. So following that logic, I might have written down that U is the same as X if we're talking about this black formula. Questions? Then you do the same thing. So we'll go to Crin. Crin, what form does the green function have?
The same.
Same form. Because it's x cubed plus 1. What's the n, Crin?
1/2.
1/2. 2 points for Crin. So Lexi, if the green formula is following the same pattern, and our U is always the something, what would we choose for U if we're looking at the green?
Would it be like the square root of u3 plus 1?
Close. Are you okay that this green formula fits this pattern?
Kind of.
It's easier to see if we rewrite it. So the square root of x cubed plus 1, 2 points for Lexi, is the same thing as x cubed plus 1, so we'll go to Sophie, to the 1/2.
Oh.
So Sophie, what's the n for the green? 1/2, and what's the u?
X cubed plus 1.
U, x cubed plus 1. 2 points for Sophie. Questions?
The reason you're doing that is because it was C's. C's like the closest.
Oh, let me back up. That's a good question. So here's my whole sequence of thoughts. To here was something we learned in Unit 4, like how to find the average of a bunch of numbers.
Yep.
So we're good there. Then I say, okay, to find that, I've got to do an integral, but I can't use my calculator, so I've got to use the fundamental theorem, which means I must find the antiderivative of this. You good there?
Yep.
So that's the new problem I create right here. I'm going to find the antiderivative of that whole thing in yellow there. Good there?
Yeah.
My next thought is I can't use a rule, so I have to use this new method called U substitution. So in trying to see if U substitution will work, I go down this little checklist.
Okay.
I say, do I have two functions multiplying?
Yep, you do.
I do. Are both functions of one of these 5 forms? They are. They're both of this form. So far as I go down my checklist, everything's looking good.
Okay, okay.
Looking good. So then I say, okay, this little note here is just a little way to help me remember. These forms look awful, like they're almost the same thing as your formulas. Your formulas say, 1 second page, sorry. Your formulas say x to the n, e to the x, 1 over x, sine of x, cosine of x. The forms are basically the same thing, just a little more flexible. 1 second page. So item D is fine, that's just a way for me to remember. Item E, I'm supposed to pick U, I don't really know why yet because I haven't explained that, to be the something. Well, what's the something? It's right here. Something to a number. E to the something. 1 over something. Sine of something. Cosine of something. So I've done that. I found that for the black formula, U would be x. For the green formula, U would be x cubed plus 1. And that's where I've stopped.
Okay, okay.
Better?
Yeah, that's a lot
2 more
better.
pages.
So the only reason we can't use like
the rule sheet is because there's two functions, and so this allows us to apply like basically the same rules but to like each function.
Not quite, but kind of in a way.
Because it's like I see what you're saying about like all those being like basically the same as the rule sheet, but like it's the first one, right? Because of like the way it's formatted, but we can't use the rule sheet because there's two of them. So
Right. We have to follow the equal sign. And the formula sheet says that the antiderivative of x to a number is the same as x to the n plus 1 over n plus 1. But the formula sheet doesn't give any equal sign for how to handle something so complex as this. So there's no way to use it. You can't it's not allowed to just kind of randomly combine the formulas. You can't do that.
And what's
That-
the name for this thing that we're doing?
There is a name. Most teachers will call what we are doing use substitution. The more official name is we are finding an antiderivative using substitution. Two more. Right.
Yes.
Okay, two more for raising your hand. Other questions? Okay, so we have two possible choices for you. Go to Daniel. The next step, it helps if we can just do it in our head. It saves some writing. Right here is a red flag. If we're making a substitution, and all we're going to do is everywhere we see an x, we just write u, we're not making any progress. The problem would look identical. Just would say u instead of x. So this is not a choice we ever want to make, ever. So we don't ever do that. Questions? So we have another choice. Let's find out if the other choice will work. So we'll go to Daniel. So Daniel, this item in green here, this choice for you, was chosen based on the first multiplying function or the second?
Second.
Yep. Came from the second multiplying function. So what you're going to do, Daniel, is you're going to take the derivative of our choice. So we go d dx to both sides. The left side can't really be written any other way, but the right side can be written another way. Daniel, what's another way to write d of x cubed plus 1 over dx? What's another way of writing that?
Sorry, like with the derivative? Or
Yep.
just- so you use the shortcut rule with x cubed, so it'd be 3x squared, and then you drop the 1.
Perfect. So 3x squared plus 0, yeah?
Yeah.
2 points for Daniel. Questions? So here's the good news. Mackenzie will help me. Mackenzie, this choice of u came from which of the two multiplying functions?
Second.
Good. We took the derivative of our choice. Is the result of our derivative an exact copy of the first multiplying function?
No.
No, it isn't, but it only differs by a multiplying constant. Yeah, the multiplying constant here is 1. The multiplying constant here is 3. So other than the multiplying constant, is it an exact match, Kenzie?
Yes.
It is. That's what we want. If you find that, then you know the process will work. If you don't find that, there's no sense continuing.
Wait, if we find that it matches.
So I'll say it again. So Ryan, this choice of u came from which of the two multiplying functions?
The second one, the square root one.
Awesome. When we took the derivative of our choice, we found this to be the result.
Yeah.
Is this result a perfect match for the other multiplying function?
The x is with the constant.
Everything but the constant. And if all it differs is a multiplying constant, not adding, but multiplying constant, we're good. That means the rest of the process is going to work, so we can go ahead and use the rest of the process. But we have to get that far before it makes any sense to continue. Questions? Cool, next thing. All right, so we kind of have to start over now that we've got a sense of what's going on. So we're going to start over a little bit. So we'll go to page 15. Let's clear off a bunch of this and start a little bit fresh. That's not an eraser. That's an eraser. So starting from the beginning, here's what we do. We're going to make a bunch of substitutions. Now, I'm very strict on this. The process is complex, and so if you don't follow my style of notation, it makes it very difficult for me to help you. It just takes too long. So just do it the way I'm doing it, and then it's easy for me to help. I can see exactly how you've organized your work. So here's how to organize. Like we've done all year, you go straight down the page. Like we've done all year, you go straight down the page for the actual work. But we also have to include a bunch of stuff over here on the side. That's why I said it takes up the whole page. So do your work straight down, but we do the extra stuff on the side. So one of the first extra things is we have to write down U. So we figured out that U will equal x cubed plus 1. We also figured out that du over dx will equal 3x squared. So we write that down. Questions? Please, Sarah.
Can you ever write U prime?
You can, and it's actually correct, but it's less helpful. You'll see why in a second. It's a good job. 2 more. Okay, Ava's going to help me. So Ava, the thing I've not really mentioned is that this finding an antiderivative with substitution means we want to replace every item that involves x. Here they are. These as well. These also involve x. Every item that involves x needs to be replaced with u, with an item that involves u. It makes for an interesting story that some student made up one time. The student said, "Oh, I get it. It's like dating." Like, no, seriously.
I don't follow.
You don't follow. Watch. It's actually pretty good. I credit the student, not me. I can't remember who came up with this. She said, "No, it's like dating. Look, you start out and you're kind of dating someone, and then eventually, whatever, you just kind of lose interest. And you're like, yeah, it's time to consider that person my ex." No, stay with me. And then once you decide to leave your ex behind, it's like once you decide, you really should decide. Is that not fair? Like don't drag it out, right? Is that not accurate? Like don't just prolong it. Like make it like be done, right? Like cut them loose, right? Okay, so you're done with the ex. Now what you're going to do is you're going to make it all about you. Forget your ex. It's all about you now. Go spend some time for yourself. Like reset. Rejuvenate. Like go make it all about you. Told you it was a dumb story. Okay, I'm gonna make it all about you. We're gonna leave the ex behind. We're done. It's gonna be all about you. There's they call that a meme. Thing up there. I can't even read it. It's so far away. Get on the chair. Anyway, here we go. So Ava, we've got to change this value from a value of x, and this also as a value of x, into a value of u. So let's do that. We have a formula here to help us. When x is 0, Ava, according to this formula, what will be the equivalent value of u?
1.
Nicely done. 2 points. Questions? Let's go to, yeah, please.
So you want us to write that off this?
Always on the side. So all this stuff over here that's us figuring out the values of u.
Yeah.
We want it over here because it's just kind of extra stuff we need. It's not like the main problem. 2 for Piper. So, Bjorn,
Yeah.
if we have an x value of 2, according to our formula, what's the equivalent u value?
7. Wait, no, sorry, no.
You're good, you're good.
9.
There we go. So we plug in a 2 cubed plus 1. That makes 9. Awesome. So we have figured out we can get rid of this x, we can get rid of this x, like that song, X's and O's. Okay, questions? Bad jokes today.
Listen, we just forgot
pockets
our
today,
X's.
actually. Were you going last week?
Yeah.
Oh, so you need this way. There you go. There you go. Okay, cool. We can do that. We can replace this. Look. Right there. That is replaceable. It says right here. You don't need to have x anymore. Make it all about u. U is the same thing as x cubed plus 1. So we can replace that. So let's do it. So this is going to say equal now because these are the same. Still have the 1/2. The integral's changing now. The bottom limit is 1 because that's u. The top limit is 9. We're going to switch the order here. That's usually helpful. We put the u first because we're going to make it all about u. So put the u first. Now we have x squared dx. Questions? Please.
Didn't we get rid of the square root though by making it to the 1/2 and then, like, do we?
We recognized that it meant 1/2 power, so we saw that this right here is of the form something to the 1/2.
Yeah.
But our choice for u is always the something. So our choice for u is just the x cubed plus 1.
So we.
So that's what was replaced. Like the equal sign rules, u is the same thing as x cubed plus 1. So square root of x cubed plus 1 is the same thing as square root of u.
So we still have to leave the square root in there, even though.
We have to because we have done nothing to legally replace it. Now we could write 1/2 power.
Okay.
Is that okay?
Yeah.
2 more for Jenna. Please.
Why is it still divided by 1/2 if it's 1 to the 9? Wouldn't that be 1/8?
Oh, it's all about the equal sign. This, that is a bit of a complex question. I'll give you the simple answer, and if it's good enough, we'll just go with it, okay? We created this integral based on the request that we find the average,
Okay.
right?
Yep.
Once we've done that, we kind of forget that we're finding average.
And you just let the numbers be as.
Right, the number is 1/2. And now we're trying to figure out how to do this integral.
Because the 2 is equal to the 9 and the 1 is equal to 0, so.
But they're only equal if we change everything. Like we've still got to fix this. Let's go a little further, it might help. 2 more. Questions? Jocelyn can help me. So Jocelyn, over here, we did it before. Well, okay, look, we're doing pretty good. The 1/2 is just 1/2. There's nothing that needs to be done there. It's just a number. This value of x equal 2 is now u equal 9. X equals 0 is now u equal 1. Square root of x cubed plus 1 is the same thing as square root of u. We need an equal substitution for that. We need something that is the same as this. So can you tell me how to use this equation to create, mathematically, something that is equal to this? And remember, long ago we talked about this really is division. du is literally being divided by dx.
So then,
divide.
We can't divide 2 points. What can we do?
Can you like rearrange it so that you're applying the dx operator to x squared?
Yeah, we can multiply both sides by dx. If I multiply both sides by dx,
You get 3x.
I get, what's this? This side will be what, Sarah?
Du dx.
Well, we're going to multiply this side by dx. So the dx will divide out.
Yeah, du equals.
It's not the derivative, it's just 3x squared dx. They're just symbols. So we get that. 2 points. Question? So Mitchell, how do I create this?
Would it be u prime divided by 3?
Except this isn't really u prime, it's just du. So this will be 1/3 multiplied by du. It's exactly the same thing as x squared dx. 2 for Mitchell.
Wait.
Just divided it.
Just divided the 3.
Oh man, okay.
Yep. So Lissy,
Yep.
Multiple choice.
that black box is the same as this black box, yes?
Yep.
That means this black box is nothing more than 1/3 times du. And now we have left our x completely behind. The x is our x is no longer in the picture. We have done the Taylor Swift thing. We have burned all the pictures.
I don't get it. You wouldn't understand.
I agree. All right. Please.
I go along with that word if we're not finding the derivative.
You're okay. So, are you okay, Piper, that...
Tickets.
Yeah, I know. Paige Piper thing. This is the only one Lily in class anymore. She moved to A2.
Makes my life easier.
It does every time I say Lily, I'm saying which one.
You know, like,
Okay. Say it again, Paige.
So the du, like, what exactly we did to get that, like, it's not, we didn't find the derivative, like, what did we do?
So right here, you're okay that we use some logic that I said we should use to state that u is the same thing as x cubed plus 1.
Yeah, like,
Good.
we decided to assign.
We decided to do that. What we then did is this. We took that equation, and just like you've done for years, we said as long as we perform the same operations for both halves, we get new equations that might be useful. So we apply the d dx operator to both halves. Are you okay with that?
Yes.
Good. There's an easier way to write this, so I choose to use the easier way. I write this as du divided by dx. Okay with that? The green rule sheet says this can be written an easier way. It can be written simply as 3x squared. But what that equation literally means is du, which means the infinitesimal difference in u values, divided by an infinitesimal difference in x values, can actually be calculated by just taking 3 times the x value squared. That's what it says. So algebra says I can multiply both sides by dx. Take this side here, multiply by dx. Take this side, multiply by dx. Because these are factors, the dx will divide. And I'll end up with du. It's the same thing as 3x squared multiplied by dx. That's what I did.
And then you just
Oh.
divided the 3.
And then I just moved the 3.
Okay, so you just rearranged.
Just rearrange, nothing more.
And that's why we don't want to write u prime, because you watch.
Right. I need the dx. I need the du. U prime kind of lose, I need them separate. U prime is a symbol that combines these together. and I need them separate.
And the reason that you could have used the u equals x cubed plus 1 equation is because it doesn't matter if there's a constant, you can just divide it out all the time.
Because the constant is easily moved. Like, let me show you that. So, erasing this for a second. So now what we did is we said, this box right here, wrong button, this box right here is exactly the same as this. So we made our replacement. We burned the picture. It's gone. It's right here. It's all about you. Please.
So the 1/2 is calculated from the x values from the range 0 to 2. So why do you leave it when you replace the x's for u values?
Because all I'm really doing is I'm just trying to figure out how to compute this integral without my calculator.
Yeah.
So computing the integral has nothing to do with this extra multiplier.
Okay.
That's kind of a short answer. Is that okay for now?
Yeah.
2 more. All right, Jacob. We have root u times 1/3 times du. The 1/3 is a multiplying constant, therefore it can be taken out of the integral. So Jacob, what's 1/3 times 1/2? 1/6. Integral from 1 to 9. Square root of u. Now we're going to go back to u to the 1/2. Du. No x anywhere. Just u. All about you. I can smell the smoke from the burning pictures.
Oh.
Questions? Cool. So, Corbin, is there a rule on the blue rule sheet that fits, like ignore the 1 and the 9, we're just looking at the antiderivative portion. Is there a way to find the antiderivative of u to the 1/2 according to the rule sheet? Yeah, top left rule. Fits it perfect. Not kinda, like it's a dead match.
It is a dead match.
So now what you write is this. You go down the page, I have to do this little loopy thing. So you have 1/6. The antiderivative of u to the 1/2, Corbin, is what?
U to the 1/2 plus 1 over 1/2 plus 1.
2 more points.
C.
2 more points. We talked last time that when we're doing an integral, we don't need to worry about the c, so we'll not write the c. We have that. So right here, we get Lily to help us. Lily, we have a formula here in orange. We have a different formula here in yellow. But according to the fundamental theorem, those formulas are very related. Here's the fundamental theorem again, right here. How is the orange formula, Lily, orange, related to the yellow formula?
Well, it's like the antiderivative of it, so it would
That's
be-
it. That's it. That's all you need. No, really. Sorry, I didn't mean to cut you off.
You're good.
That's it. The yellow is the antiderivative of the orange. The yellow is the antiderivative of the orange. The fundamental theorem says if you're trying to integrate orange, you have no calculator, don't do that. Go find the antiderivative of the orange, which would be the yellow, and then plug into that yellow formula the 2 limits. So that's what we're doing. Questions? So Brinley, what are we dividing by over here? Which is the same as? Close.
Wait.
It's 3/2.
Yeah.
No worries. So the bottom is 3/2. Well, dividing by 3 over 2 is the same as multiplying by 2 over 3.
Yeah.
So dividing by 3 over 2 is the same as multiplying by 2 over 3. So this is the same as 1/6 multiplied by 2 for Brindley. 2 over 3, u to the 3/2, evaluated at 1 and 9. You leave x behind, do not go back to your x. Everything is about you now. Solid advice. Okay.
Wait, the u is multiplying those other two numbers.
These are constants,
Yes.
so those multiplied together reduce it a bit there. So like these are factors or terms, Piper?
Factors.
Good, so we can choose the order.
Yep.
So I'm going to do 2 divided by 6, which is?
3.
So we got 1 over 3, right? And then 3 times 3 is 9. So this is really just 1/9.
Oh, I see.
Now you just plug them in. Questions? Please, Sarah.
How do you like I don't know what 9 with 3 squares is off the top of my head. But
Oh,
it's like,
you don't need to worry. I'll show you. It looks terrible. It's not that bad. Good question. 2 more. Daniel.
When we went to the antiderivative, isn't there supposed to be a c that we just do a plus c?
There would be a plus c, but because we're going to take the antiderivative, plug in a number, and then the same antiderivative, plug in a different number and subtract, the c that would be over here will add with a negative c over here, and there'll be 0. So we don't have to write the c if we're doing an integral. 2 more. Good? So Hannah's going to help me now. So we have 1/9. That's a constant, so I'm just leave that out front. Now doing what Sarah did, I take the 9, plug it in. So 9 to the 3/2, subtract 1 to the 3/2. Okay, 3/2 power, Hannah, means I have to do a power and I have to do a root. I have to do a power and I have to do a root. The power is 3, the root is 2. Which is easier, Hannah, to take 9 to the 3rd power or 9 to the square root, or the square root of 9? Good choice. I don't know what 9 cubed is. Don't think so. I do know what the square root of 9 is. What's the square root of 9? Okay, now you have a 3. You still need to do the power. So it's now 3 to the 3rd, not 9 anymore, because you did the root first. So what's 3 cubed? 27. Oh my heck. 2 points for Hannah. Ryan, what's 1 to the 3/2?
Just 1.
Just 1. Okay, we're done.
That's all you have to write.
2 points for Ryan. If you type this in your calculator, type that in your calculator, you will get 26 over 9.
Yeah. 1/2, which is so that you found the square root, and then you were left with.
Yeah, here's why. Watch. See if this helps you.
Wouldn't that be good?
Let's write it down in more detail. So what I did was this. You've got 9 to the 3/2 power, okay? Look, Piper, if you had x squared times x cubed, what does x squared really mean?
2 x's.
X times x. What does x cubed really mean?
X times x is 6.
Right, so you really got x times x, and then you've got x times x times x, which means you really just have x to the 5th power.
Yeah.
Comfortable? So that's a little reminder that in this situation, we could have just added the exponents and that's what we have. Comfortable?
Yep.
So this is going to use the same process. You've got 9 to the 3 over 1. Oops, back up. I don't know if I can show it this way. Hold on a minute. Is this going to work? Maybe not. I don't know. I have to think about that one, Piper. I'm sorry. I know it works. I can't remember why it works.
But what you were doing is you took the 1/2 and then you made it so it was.
Yeah, here's what I really did. This is not helpful. I'm sorry I gave the wrong explanation. What I did is I said this is the same as 9 to the 1/2 power
Yep.
raised to the 3rd power.
Oh.
Like this. X squared raised to the 3rd power is really just x times x to the 3rd power, which really means that's just x times x 3 times. So it's x to the 6th.
Not x to the 5.
Yeah, that was a bad example. So that means these exponents are multiplying, right? Just like these. What's 1/2 times 3? 3 halves. But what's 9 to the 1/2, Piper?
3.
Good, so now I have 3 to the 3rd power.
Okay. That.
27. That help?
Yes.
Cool. We're done. Sweet. Stop the video. Any questions?